Hello to you. I'm Jesse R. Johnson. I'll be speaking to you today about propulsion, specifically graphene accelerated platform propulsion using laser light. Now, there are two types of propulsions, open and enclosed. Macroscopic acceleration of mass, that's M-A-C-R-O, macroscopic acceleration of mass can be done with light using 100% pure graphene, which are very thin layers of carbon. Acceleration by light using specific wavelengths and wattages, giving the graphene lifting power in a vacuumed and totally enclosed system. Open propulsion includes, number 1, land, such as automobiles, trains, etc. Number 2, air, such as planes, helicopters, balloons, etc. Number 3, water, such as boats, submarines, etc. Number 4, space, such as satellites, rockets, etc. Land is mainly by friction. Air is mainly by air displacement with propellers, jet engines, or balloon, or balloons. Water is mainly by water displacement by propellers. Space is mainly by thrust. With propulsion, thousands of miles or more can be traveled by a vehicle system. With levitation, only just a few inches to 1 or 2 feet. With hovering, thousands of feet up in the air with helicopters and balloons. Open propulsion requires getting rid of fuel or pushing or pulling or displacing gases or fluids externally. Enclosed propulsion, on the other hand, is in a bounded volume. No energy enters or exits the system upwards of 99.9%. And it does not require anything externally to help it move. It is totally enclosed. Now, to begin. First off, I'm going to move the camera. Please hold on. Now, to continue. This here is illustration A. Illustration A. This is a side view of a small-scale example of such a propulsion system. Number one is here, are graphene sponge spheres, or GSSs, about the size of small pearl beads. There are 25 of them making up the front part of the system here. The front part of the system. There are 25 of them. Now, number two is right here, is the super lightweight housing, of which it is number seven, that's here, number 7, which is vacuumed out of all gases, upwards of 7 times 10 to the minus 4th power of torrs. That's TORRS. Now, number 5 is here, is the laser source. It is of wavelengths of 450 nanometers at 1.9 electron volts or more at 1 to 5 watts or more per centimeter squared density intensity. Now, this laser, number 5 here, is turned on and goes through number 6 right here, number 6, which is the injection point of the laser light. This light is reflected or focused by number 4. Number 4 is right here. Number 4, which is the super lightweight mirrors or light wave guides to each number 1 or graphene sponge sphere in the form of number 3's laser light beams. Number 3 is right here, and these are laser light beams going to each one of their specific graphene sponge spheres. And number 2, the total housing itself is then starts to move, accelerated in the direction of A. Now we shall go to illustration B. This is illustration B, which shows how the number ones, which is the graphene sponge spheres, are situated in their own specific number 8, which is the graphene sponge spheres compartment, the graphene compartments, and of which a separate number 3, a laser light beam, contacts and impinges on and forces the graphene to lift. Now we shall go to illustration C. This here is illustration C, which is the graphene mechanism. The graphene mechanism shows a number 1. This is a graphene sponge sphere, a number 1, with a number 3, a laser light beam contacting it and impinging on it. It is a single beam impinging on it with E. E are electrons. E are electrons. Are the electrons moving in the opposite direction of the beam. The beam is going in direction B. The beam is going in direction B, and the electrons are going in the opposite direction. The opposite direction, which is C. Now, of which number 1 itself, the number 1, which is the graphene sponge sphere, moves in direction B as a whole, which is the same direction as number 3, the laser light beam. Now, number 3, laser light beam, do not ablate, A-B-L-A-T-E, it does not ablate or burn away, melt or vaporize away the number 1, which is the graphene sponge sphere. It does not touch it except that it puts in a steady amount of energy into number 1 and raises the energy level of its electrons, not the whole atom, but its electrons only, making some of these electrons escape by what's called Auger electron tunneling. Now, we shall go to illustration D. Illustration D. Now, illustration D shows a much larger system of 5 feet by 5 feet by 2 inches thick in dimensions. A number 5, which is a laser source, is situated under 5C at location 9. Location 9. It is this laser source, which is a 5, is situated here, number 9, under 5C, which 5C is a super lightweight mirror bed. It is a mirror bed containing so many mirrors and focusing mechanisms, which uses, and number 5 uses number 6, which is the injection point of laser light, into number 4, which is super lightweight mirrors or light wave guides, which makes up the total 5C, which is a super lightweight mirror bed. And this laser light is reflected or focused to each, and which reflects and focuses a number 3 a laser light beam onto each separate graphene sponge sphere. All graphene sponge spheres make up the 1C. The 1C is the graphene sponge sphere's bed. This whole thing is a bed. The top part and the whole thing at the bottom is a super lightweight mirror bed. And which is 1C is yellow, 5C is is red. And this total system, the whole platform, lifts and moves in direction A. It is called the acceleration platform, which moves in direction A. I want to thank everyone for watching and listening, and have a good day.